So we've been working on this, which is the variable hypercycloid, and what we want to do, of course, is get something useful out of it, and a fair few of the videos we've been doing have actually been based on this, and I think I'm about ready now to actually create the final thing. I think we've covered all the mechanisms that we need to cover that we haven't covered before. Of course, we're adapting something like this. This is a display model so we can see how it works. As a practical device, it does need a little bit of changing, and that's the first task to do, to change it into something that I want it to be more like. Now, because I'm thinking of a bicycle CVT, being able to change gear ratios in a bicycle. For that, this worm drive is perhaps no good. What I really want is a lever that works against a spring and maybe has a handle that I can pull to do that. So the first thing to do is to create something that is going to, well, fit in a bicycle hub, really. Now this is what I've created. It's a little oversized yet because I'm still not sure how this is going to actually work. I want to put those mechanisms together and see if the whole thing works, but it would fit inside of a wheel hub, and we can't make this much thicker than a wheel can take. So we have constraints on the size of the thing. And that's all one printed piece, and in there sits, here we go, the gearing that we had on the epicycloid. It's this ring here that's movable. So that will sit there and we'll be able to move that backwards and forwards. To move that backwards and forwards, if you remember, we don't need to move it more than 90 degrees. So in the side there's a slice cut out because I've got a handle. The handle goes into, there we go, a notch in there. Gets glued into that notch. That then feeds into the slot that we've got, so we can feed it into the slot. We have a retaining ring that holds the retaining ring in place. Of course, the drive, which is this here with the bearing, goes through in the centre hole, and that bit goes on there like that. And now we can actually move that around and change that relationship just by sliding that handle. Now, of course, what we'll actually do is put a cable on there with a stop here and a spring so that we can pull it up against the spring to change the gear ratio. So that's much more like what I want. Now, of course, in order to get this to work, we need this slide arrangement on it. The slide arrangement that we've got here won't do. So what I've done is create this slide arrangement that has notches here and here where we can put the slide in and little indentations, because that goes on like that, and it has a marker called T. T goes on there and snaps into place. Right, this small slide snaps into this slide guide by basically forcing it in there. So force it in there, there we go. Then this goes on the peg here, and you'll notice on this main square there's a couple of notches here and here, so it goes that way around, and again we just force it into there with that peg in place. Like that. So once we get it into that form, what we've done is reproduce this, but in a more compact form that I think is more usable for my use case. And of course, if I turn that, that will move unless I change the position when the distance that moves changes. Now, of course, given that I want to use this in the back of a bike, having it exposed like this, which is cute when you want to look at the mechanism, isn't actually much use. What we need to do now is convert that linear motion back to rotation, but in case of things, so it's protected. And so we have this plate. This plate fits over there and clips into place like that. What we now need is the reciprocating rack that we made in video 2399, and I'm using this one, which is the clutch bearing version. You could use the ratchet version if you like, but I'm using the clutch bearing because it's quieter and more accurate. And all we do is take the rack, which now has an indentation in the back, that slots onto the peg there, then this slots into the two holes waiting for it. Like that. Now I can finish this bit off by adding the cover plate, and the cover plate just slots into place. Like that. Now, this is nearly finished. Every one turn I give of this will get 2 turns out of that when it's at its maximum. When it's at its minimum, every 1 turn I turn of this is 0 of that. So we're going from 0 to 2 to 1. Now that might not seem like a lot. I mean, you know, it's only a 2 to 1 gear ratio. But we can change that by mucking around with the gears in here. Or we can do something like add that. That obviously is a planetary gear system, and it's a 6-to-1 gear system. So if I put that on here, gears, remember, don't add, they multiply. So what I'll get is a 0 to 12-to-1 that I'm able to do by just moving that handle. Okay, let's put that on and the final cover plate. So the final plate just slips onto there. There we go. Line it up with the notches and press it in, and then we're ready to go. Right, I've put a couple of dots on it, one right there and one right there, so we can have a look at the relative positions. Now, with that lever, there we go, that lever there, far over here, of course it's in the 0 position. So I can turn that as much as I like, and of course there's no output, which is what you want and what you'd expect. Now if I move that lever, so I slide that lever up, then what happens, of course, is we get output. There we go. Question is, how much? So we'll rotate that dot by 1 and we'll see how far that dot travels. Okay, I lost count. I did one rotation of that. I lost count of that. So I'm going to try something different. We'll rotate that once and see how far that has travelled. So let's get that rotated once. There we go. And the dot has travelled from here to here, about 1/6 of the way. So there we go. I think that's pretty awesome, actually. Now, I appreciate that was a little hard to see, but you know, it worked really quite well. And of course, I will put these on Thingiverse. Should anybody want to test whether I'm talking absolute BS or not, you just have to print one off and see for yourself. But it certainly worked as far as I could tell, and I hope as far as I could demonstrate. What we've got here is a combined continuously variable transmission and clutch, because of course with the lever here we have a 0 position and no output, and as we moved it along we got variable output. So it depends on the position of the lever to what the actual gear ratio is, and the gear ratio of this one is from 0 to 12-to-1. Obviously we have our input cog here and our output cog there, which would be the wheel. Or, of course, we could try and get this into the hub. Now, it's still a little bit chunky, granted, but then I've really just been working out that these 3 components we put together actually work together, which I'm quite pleased to say they do. Now it needs a little bit of redesign to make it less chunky, but not by much. Anyway, I hope you enjoyed the video. Thank you very much for watching. These will be on Thingiverse, and please do remember to like and subscribe.